Well, my talk is going to be about dynamic content with Angular, and I called it a journey because I'm going to take you on a journey of how I thought about dynamic stuff in Angular and what turned out to be a way to work with it. But I'll take you through all of that through this next maybe 30 minutes or something. Yes, so my name is Filip. You can find me on Twitter. Of course, you should follow me right away because I'm cool and stuff. I work at a company called Impact. We work for a lot of the big Danish clients. And of course, you know, I'm the organizer of this group, and we're growing, and it's cool. Last year, I got accepted into Google's expert program, and I'm pretty excited about that. And that's also, you know, part of why I'm here. But enough about that. Let's talk about Angular and dynamic content. So the obvious starter question is why are we even talking about this? So what we do is build websites that are more or less run by a CMS. So we need CMS editors to be able to change whatever is running on the website, obviously. And we need Angular to kind of work with that and not against that. And you know, when Angular 2 was announced, it seemed so awesome. Like it seemed like something we would do. So I thought to myself, let's try to do it like we do Angular 1. So we'll just start up, bootstrap the application on the body element and get started. But obviously, we can't do that because we need to bootstrap a component with Angular 2. So I'm assuming you know the absolute basics of Angular 2, and if you have questions to that, I'll take those at the end. But for Angular 2, it looks a little bit more like this. So we have to declare a module, and on the module we declare what component it should bootstrap. So we can't just bootstrap on any arbitrary DOM element and expect Angular to figure out what's on the page. So obviously the problem is what do we do when there's no root app? So there's no application around everything. So we can do multiple entry points. Like you saw in this slide, the bootstrap is actually an array. So we could just put in multiple components to bootstrap, and that would actually work. But it makes it a little hard to maintain state when it's not one application running, but it's multiple applications running on the same page. It's possible you can do stuff with shared services and stuff, but it's a little hard. And the big problem really is that for that to work, we need the CMS to know, you know, what components are Angular components and what's just, you know, regular tags, because we need to tell the framework what component it should boot up. And we can't just put all available components in the bootstrap array, because if Angular sees something in the bootstrap component that's not in the bootstrap list, that's not on the page, it'll actually just fail and break. So you can't really do that. So you think to yourself that you could just do bootstrap, gallery component, basket component, blah, 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 but it doesn't work. And we need to pass some initial data in. So maybe, like if you're used to working with a CMS, or how we did in Angular 1, we would just, you know, feed data into to our components through maybe a JSON object, or maybe just even through DOM elements nested inside a component, and then use transclusion or something in Angular 1 to make that light up. But you know, something like, you know, template is ng content, which is where the transcluded stuff would go, and then have an input called basket or something that would be settings. But again, you can't do that because it turns out that root components, they can't have inputs, and they can't use content projection. So the two kind of ways to do this approach via these things, they don't work. And there's a long GitHub issue, and if you have time one day and want to learn stuff, you should just read that issue. And it's there's a lot of crazy stuff going on, but it's a performance optimization. They don't allow that. So I thought to myself, I'll be a little hacky. We'll do a body component. So this should be pretty straightforward. We'll make one root application that's the body body tag, and we'll just set the template to be document.body.inner.html. It just feels wrong. It actually can work this way, and during some of my initial prototyping, I went along with this for a while, but it feels so wrong. And just reading directly from the inner HTML string of the DOM, and then to just put it back in the template and then load it out again, it's just wrong and weird. And another problem is that means that we would actually need the parser at runtime. And one of the selling features of Angular is that we're actually able to do all the template compilation on the server or in the build step, and not ship the parser down, so we can have a really small bundle size and we can have really fast and efficient code. But we can't do all that crazy stuff if we need the parser to actually be available at runtime. So no ahead of time compilation and bad performance, not so fun. So we need a spa. We need a single page application, so we can share states between different pages really easily. We can animate route changes, so when you go from one page to another, you can actually do custom animation. And a lot of other cool stuff, and single page applications are more or less the way applications on the web is going, and maybe even all websites will eventually go this way. So I thought I recorded just a quick demo just to show what I was looking for, what I was aiming for. And beware, I'm not a graphical designer. So I made this thing. And so this is a really basic page. I just navigate through a page. There are different page templates. I can go to a product page. It'll lazily load products in. I can scroll up and down, and it's really fast and smooth. And this is actually the end product and the code that's in the repository that you can go ahead and download and play with if you want to. And when we're building a single page application, I'm waiting for this to actually change my slide. Good old Keynote. There we go. And maybe it was the 50 megabyte GIF movie I just showed you. So in Angular or with any kind of single page application, it all starts with the router. So in Angular 2, in our Angular, it looks kind of like this. So we define an array of routes and say, so if the path is nothing, you go ahead and show the front page component. If it's /products, we'll show the product page components, and we'll do all the available routes this way. That's not very dynamic, because we have to know all the routes. We have a lot of different routes. Maybe just / is a front page, and about us is a content page, or this is a category page, or a subcategory page, or a product page, or there's no real clear. So you can't really do a regex that will find these efficiently for you and say, so this is this kind of template and this is this kind of template. So it doesn't really scale that well. So I talked to the Angular team. So I went to a conference and I met some of these guys, and I was like, so how do I solve this? And they were like, let the CMS output route configs. There are two main issues I have with that. It could work in some cases, and it would be possible, and it'll be doable. The problem is that every time an editor in the CMS creates a page, or deletes a page, or changes the template of a page, we would have to output new route configuration. So we would have to invalidate all the caches, or at least the cache for that specific file, which wouldn't be too awesome. And another problem is that we have so long sessions now. So when we could have people loading the website and then closing their laptop and going on vacation for 2 weeks and coming back and just opening the laptop, and they want to just click the next link and continue where they were. But all the changes that the CMS editors have done in the meanwhile, they would never get those because there's no refresh, so that they won't get all the new route information. So those are some pretty serious issues with that approach. So I thought to myself, I'll do one route to rule them all. So if you've seen or heard any of my previous talks, I've talked a little bit about how I did this in Angular 1. I was looking for maybe a way to do the same kind of approach. So this is the data that I want the server to kind of spit out. So I want my application to load and then ask the server, so for this URL that I'm on, what should I show? And then the server will respond with something like this, that is a template. So you should now use the front page template for this route, and some data that's specific to that model or that template or however the CMS works. So this is some more generic content or dynamic content with an array of spots that could be anything. So they might be a gallery or a product or whatever. And then there's on this page there's also some hero image stuff that's just specific to the front page because it's not on the other pages. And that will actually we need that to end up rendering the beautiful stuff on the right. So we would do star route, which is the Angular way of saying all routes should just match this one route. So we do path is star and say component is a generic page component. We'd then get the data in the resolve. So if you're used to the UI router in Angular 1, or a lot of other routers have some kind of resolve functionality, so they can do stuff while you're changing from one route to the other. Then the route here would through this service. I just put this here so you could copy the code if you wanted to. So a resolver is just a class that has a resolve method on it that's being called with the route, and they'll then return the data for that route. So yeah, this is not really specific to the solution, but that's just how a resolver works. So in Angular 1, we could then use a template factory and select a template based on the API. So when the API says use the front page template for this route, we could just use the template factory and say get the template for the front page and use that. But as I said before, we don't have the parse at runtime, so we can't do this because we can't just give it a template and have it render that template. So I thought to myself, so we'll just put all the available page components on one page and put ngifs on them all. So you see, here's a template. We get the data in the constructor. Here's a template that says, front page. If the page data template is front page, use that component. If blah, blah, blah. You get the point. And I put this slide in again because, it just feels so wrong. And I mean, I know when we ahead of time compile this, it'll actually turn into something that's not a template being passed. It'll be, real if statements or something. But it just feels so wrong to have this logic going on in the template. It just shouldn't live there. But for now, it works. Until you start navigating around. Because it turns out the way the Angular router is built, when you're going from one route to the same route eventually, there's no route change. So we don't get the resolve, we don't get the on init, we don't know that we've changed. So I started refactoring. So we can listen for route changes. With Angular, there's an observable for that. So we can just subscribe to that observable and say, so every time the route options change, we can do something. So this is the same as just before. And here we listen for the activated route URL observable. The filter, don't worry about that. And then we use a switch map, which just basically does the resolve functionality that the router did before. We'll do it here in the class. We'll get the data, we'll put that on the page template, and we're back to working. So now we can actually navigate around, and the ngIfs will kick in, and we can switch the template. The problem is, though, that this problem will cascade, because the same issue will now be the issue if you go from one product detail page to another product detail page. Which means we will have to refactor again. So now we'll need all of our available page templates to not work with on init, but work on unchanges, and then do the same kind of stuff. It doesn't feel so good. So this was about maybe 6 months ago. I was at this state. It was Angular hadn't really released yet, and if you've followed along back then, a lot of stuff was going on. A lot of breaking changes came in the release candidates, but also release candidate 4 brought us beauty to dynamic content in Angular. So the theory is we'll get a factory. So we via dependency injection we get the component factory resolver, and it almost feels like Java now because we're just calling the function that has all the words in the opposite order. So we'll do company factory resolver dot resolve component factory, and the idea here is that you call it with the component. You don't call it with the component instance, but with the component that's actually the one that's being newed up for this instance. And what the component factory resolver will give you back is actually the factory for that component. So it's a little bit, you just have to try to understand how it works and get it in your head. But when you understand that, that's actually how the router works. That's actually how all new components are being used internally by Angular, is by building a factory for it and then instantiating it from the factory. And then, the line, 20 and 21 is just actually making a component from the factory and then putting it in the view and putting the data on it. So, the practical stuff to actually get this works, I made a generic page directive. So this is the same component as you saw before, but instead of all the ugly ngIfs in the template, here we just have a div that has a generic page directive on it and the data. And then all the rest is the same. And then the generic page directive looks kind of like this. So it just listens for every time the data changes. So every time there's a new route. If there's data, because it will be called the very first time without data. But if there's data, we'll clear whatever is already in the view, and then we'll just do the same thing again. So we'll get the factory, create a component by the factory, and then put it in the view and put data on it. So that begs the question, so what components should be available this way? And how do we know which one to pick or where to pick from? So I made a basic array, which I called page components. So this is just a list of all the components that should be available for the router or for the routing mechanism to actually to show up as a page, as the template that'll actually be run. So I made this list, and the thing on the right is just more or less an implementation detail with the static reference on it in line 17 on the class that makes it possible that when I'm looking, like in the slide before, no, this slide? Yeah, so in line 20 where I'm doing page components.find, I'm actually just looking up on the class and not on the class instances and selecting which one is the appropriate one based on the static name. So the name here in line 17 that says front page is in a string compares to the name from the JSON blob that says use this template. So that's how it's built together. If you're building a library for somebody else, you should look into analyze for entry components, which is kind of a different way to organize this stuff. But it's you should look at Sean's talk from NG Vikings. So basically, we have all we ever wanted now. We have the dynamic stuff. We have none of the ugly template stuff, and all of the good stuff. All of the bad stuff is away. So now we have ng on init on all our templates because they're actually being instantiated over and over again, even if it's the same template again. And that's pretty cool. And then of course, ahead of time compilation. Now it just works just out of the box. It works with dynamic components. And if you've played around with the CLI, AOT is so incredibly easy, like you wouldn't even think about it. So you just call ng-build, put an AOT flag on it, and that's it. It'll build a bundle for you that's a lot smaller and runs a lot faster. So the only thing you need to add is to tell the AOT compiler, which does tree shaking, so it doesn't shake away all these page components that aren't referenced by anything by this time. And the way you do that is you put it in the, like when you're defining your ng module, you make an entry called entry components, and you can just put all the components in here that aren't being used by any other template. Because that way, Angular or the tree shaker won't shake away those pages, because otherwise the components wouldn't be there at runtime. And I've chosen to use the spread operator just to make it clear that I'm actually spreading out an array of or a list of page components, but you don't really need to, because the ng module stuff, it automatically handles merging nested arrays. So now we are at faster and lighter. So just by adding ahead of time compilation, our startup time of this proof of concept of a dynamic single page application goes from about 450 milliseconds to 250 milliseconds. So we have a really fast Bootstrap time with ahead of time compilation. And of course, the even more important part of this is the bundle size is now a lot smaller. So you can see that without AOT, the vendor bundle, which is Angular and all its dependencies, is 4 megs. And with AOT, it goes down to 700Ks, and with gzip, it goes down to 170. So this takes your application from being a huge monster to actually shake away all the stuff that you don't use, and gives you a final application that's less than 200 kilobytes. So that's pretty cool. Obviously, the same approach goes for all the content spots. So I showed you the array of galleries and text content and whatever was on that list. And the same approach goes. I won't go into to show you that. But you can find it in the repo, and you can see how it works. The next question is, of course, how do we handle server-side rendering? So we need server-side rendering for SEO. Google says that they do JavaScript in the crawler, but they don't really, and all that stuff. But even if that was fixed, even if Google actually did it, we would still need this for social previews, so you can actually share your application on Facebook and have the right content be available. And it also gives the user like a perception of it actually loading faster, because the content is available before the application actually bootstraps. And if you use some of the newer features of Angular Universal, it'll actually go ahead and start recording everything that happens in the browser from when the server-side rendered stuff goes in and until Angular bootstraps, so that if you have a button and the user clicks the button before the Angular has actually started listening for the button clicks, the tiny little framework will listen for everything that happens, and when Angular is ready, it'll replay all the events. So it'll actually work. So you can actually have an application that, even though it's not running, the user will feel like it's running. Angular Universal is the framework to handle server-side rendering. It's so hot right now. It's going into core. It's being handled by the Angular team now. But it's pretty hard to get your head around. I'm sure maybe in the panel later we'll talk about how server-side rendering is dealt differently in React or in some of the other frameworks. Of course, they all do the same basic thing of running all the JavaScript on the server and then outputting a string with the HTML in it. But because of the way Angular's module system works, it's a little bit different. So I thought to myself I would explain it in one slide, but that wouldn't really work. So I thought I would start out by explaining how the idea kind of works. So normally you have your app module that runs your application in your browser, but now you'd abstract that another way and have a client module and a server module. And these modules will then import your app module. So that's basically the very basic concept about how it works. Then the server module and the client module will override some of the dependencies so that whenever you ask for HTTP or whatever service you would want that's not on both the client and the server, it'll actually get the appropriate one for you. So when you think about it this way, it's not that hard to wrap your head around. But when you download the massive repository and start playing with it, it seems taunting. So keep this idea in your mind, and it's actually pretty easy to get going with. One thing is though that obviously you can't touch the DOM. You can't touch anything that's related to the DOM from your code directly, because that will break in Node or on the server. So you can't do query selectors, local storage, anything on the document on the window. And Angular has been like since Angular 2 was initially thought of, they had this in mind. So there's very small wrappers around everything. So instead of just saying give me the element and then just say element.style.something, there's a renderer wrapper that will actually handle not only this and on the server, but it'll actually also handle if you're outputting to native script or something that will actually run on a phone instead. So if you use the best practices, you shouldn't do this anyway, and it's actually pretty straightforward. So just to show you the code, what I just said. So I made a main module, and that module more or less so this is the browser module and the node modules file. And they more or less just import the universal module that does all the overriding and then imports your app module. The rest of it is more or less wrapping around stuff that we don't have to worry about. So one thing we have to think about though when we're talking about server-side rendering is how do we maintain state from the server to the client? So let's say we're calculating something based on a value that we are doing math.random on or something to calculate a background color or something. We don't want the client side or the server side rendered stuff to show up with a pink background, and then when Angular bootstraps again, it'll actually redo the calculation and then change the background to be blue. So we don't want anything of that kind to be different. And obviously, if from the server I've just asked another server or the CMS or something about page configuration, like I just said before, from the router. We don't want all the routed stuff to be or all the server-side rendered stuff to go into the client and then ask the server again and re-render everything. So we need to kind of figure out how do we keep something persistent from the server to the client. And obviously, Universal has a feature for this. It's called the Universal Cache. And it more or less is around two callbacks that are being called. So on the server, there's a do dehydrate function that's being called on the constructor or on the main class, and that will actually take they'll be called when the server side is just about finished with its stuff. Then we'll call this callback for you. And in that callback, they'll provide you with the universal cache object, and you can put stuff on that, and that will then be persisted to a string. So you can give it an object. It'll JSON stringify it. It will put it on the window object in the source, so that when your client side wakes up, you call do rehydrate. And it'll read from the server, read from that script tag with all the JSON blob in it, and put it back in the cache. So that's how it will work, and it's actually not that hard to get into your head. And then we're pretty much it. So now you see this is the server side rendered part of this application, and we have all the pages. We have the images that came from the gallery component. And we have the universal cache here down the bottom, just to show how the data is actually being passed from the server to the client. So that's pretty much it. We made it. Here's the link to the GitHub repository, and we have time for questions. This was 29 minutes, 40 seconds. So questions? Yep.
I tried to do the same thing, and what I found out is that when my universal app renders on the server, it also puts in the style tags in the DOM.
Mm-hmm.
And then when Angular 2 hits in, it redoes the style tags right out there. Did you find a way to fix that?
No. I honestly don't care much for how Angular handles styling, so I try to avoid using the style features. So I haven't even run into that issue because I don't use it. But maybe somebody else has. Hmm?
I'm curious, like, what types of CMSs do you use? Because it seems that you are only, well, it's basically just a JSON API.
Mm-hmm. So we want this approach to be agnostic, to don't worry about what CMS is on the back end. So we should be able to use any kind of CMS with any CMS that will output JSON for its page models should work with this approach. In Impact, we use Sidecar and AP Server primarily, and let's just say it's a little easier in AP Server, but we made it work in Sidecar as well. Well, I guess it's my cue to say, there's one.
Do you know of any projects that makes this work on Angular 1?
Yes. Yeah, obviously the ahead of time stuff doesn't work with Angular 1, but the whole idea of making routes that will render a different template based on, or render different stuff based on the server feeding back inputs. Yes, I've made that before. We've made that before here as well. We are just about a week from deploying a really big solution that's on this platform, and maybe when the video is not recording, I'll tell you what it is. But yes, you can come talk to me afterwards, and I'll show you a repository on GitHub that has that exact features for Angular 1.
It's daunting. What Filip is saying. You understand what he's saying?
It seems advanced.
It is a little bit advanced, but I went through a lot of hoops initially to start to get this working. But I actually think that the stuff we ended up with was pretty simple. It's cool when you can work for 6 months on something and it ends up being 6 lines of code.
Everything we do is trial and error.
Yeah.
It's the way you just figure it out.
So, if we don't have any more questions, I think we should take 5 minutes, and then we'll set up for the panel and be back. Grab a beer now that we'll go into a more loose style. So see you in 5 minutes.